Welcome to this lecture, which is dedicated to upstream processing, dealing with preparing high-quality fermentation feedstock from a diversity of first and second generation bio-based raw materials for further conversions into a range of chemicals, fuels, and energy. We introduced the sixth generation of fermentation feedstocks in the previous lecture, and in this lecture we will focus on generations 1 and 2. Much of the useful technologies are related to common agro-food products, or those from forestry such as the pulp and paper industry. Also in those cases, the raw material or feedstock does not automatically fit into the process equipment and must be prepared to make it fit. The structure of first and second generation feedstock was discussed earlier in this course. The conventional fermentation feedstock such as sugars and starches are produced by mature agro-food processing technologies. This opens the biomass structure and recovers the sugars and starch products. The lignocellulosic residue was originally considered to be a waste product, but is now increasingly used for the combined power and heat production in the biorefinery. Since there is often overproduction, alternative uses of lignocellulosic biomass, such as for the production of liquid fuels and chemicals, are emerging. This can add potentially more value, but also require more investment. Pretreatment is needed for both types of biomass, but is more complex for second-generation feedstocks. Also, other products can be recovered, such as oils and lipids, proteins and nutrients. Each of these require dedicated technologies and will not be treated here. The structure of the upstream processes is rather uniform, but technologies are not identical. The common overall structure requires first to wash off dirt, then mechanical step for size modification and selection, opening the biomass structure, depolymerization when necessary in case of lignocellulosics or other biopolymer, extraction of fermentable components such as sugars, further conditioning, for instance, to remove inhibitors, and finally conversion to the desired products with or without purification. For the second step, there is a multitude of milling, grinding, cutting, chopping, slicing, mulching, and shredding technologies available. There is even very specialized equipment such as a Tilby contactor that can split, scrape, and sort sugarcane in one go. Also, for particle size selection, there are many methods. The exact equipment depends strongly on feedstock and application, and here we only show a few examples of the possibilities. Besides side reduction, pelletizing is another form of side modification. For proper performance, some additional and very practical aspects must be taken into account. These deal with removal of undesired objects, such as knives, bottles, and stones, and processing time as well as prior and subsequent storage are critical, since in most cases we deal with living and metabolizing plant material. It is also subject to fungal and animal invasion. Also, even regular drying on air can change the biomass structure strongly and make subsequent steps even more costly and difficult. Transport of biomass to, in, and from the processing plant is also a key aspect. Note that broad particle size and density distribution could give rise to particle segregation, meaning small particles grouped together as well as larger particles, leading to uneven flow. A potential solution is to standardize the particle size distribution, for instance by pelletization. Since the operating range of this sort of equipment is limited, another aspect is the operational robustness. Mechanical processes often lead to equipment wear, and for instance, the most sensitive parts need to be replaceable. And last but not least, the large scale of operation usually also gives rise to a high power consumption. This is partially dissipated in the feedstock, leading to thermal and other related effects. When the raw biomass is processed to more or less uniform particles, these can be treated with high temperature, acids and bases, and/or chemicals such as solvents to make the structure more permeable and facilitate depolymerization of lignocellulosic fractions. Important criteria are the amount and efficiency of chemicals and energy use. This varies greatly with the various methods. This can be measured in terms of final yield of sugars, but also which and how many byproducts are formed. This also depends a lot on the feedstock used, which is also subject to seasonal variations. This slide shows a more elaborate comparison of the options mentioned on the previous slide. It should really be seen as indicative and certainly not absolute. Some of the chemicals used for pretreatment also have an effect on the depolymerization of the biomass, especially the acids and bases. Another route is to use the natural process of enzymes. The latter are not only used for processing lignocellulosic feedstock, but also when first-generation feedstocks such as starches are used. The next critical step in preparation of the feedstock for the conversion process is the efficient extraction with water of fermentables, which are often sugars. This can be regular C6 sugars such as in conventional sugarcane and sugar beet processes, but also hydrolyzed sugars, which are mixtures of C5 and C6 sugars plus the byproducts mentioned before. For reason of efficiency, the extraction with water is done in a counter-current way. In sugar beet processing, this is in a so-called diffusion tower, whereas for sugarcane, this is done in a cascade of counter-current mills that each act as an equilibrium stage. Starch is usually recovered as a particle stream, since starch itself is also a food product and subsequently liquefied. In case of lignocellulosic biomass, the lignin part can either be separated from the hydrolyzate before or after the fermentation and then valorized or burnt. The extract stream is sometimes treated further to adjust color and composition, but this is very specific for the various feedstock conversion technology combinations. In the next lecture, we will take a look at some examples of first and second generation feedstock and bioprocesses. See you at the next lecture.